Today we'll study about types of discontinuity. So there are three main types of discontinuities. Number one is point or removable discontinuity. So let me clear this by a graph, by drawing a graph, X and Y, let's say. Okay, let's say we have a function like this. Like this. So here we will have some value. Let's say 4. And here, let's say we also have 4. Okay. So this is point or removable discontinuity. As you can see that if we consider to redefine a function in this point, it x equal to 4. So we can do this. So let me tell you what do we mean by continuity. F is continuous. If and only if limit, let's say f is continuous at x equal to a. So as x goes to a, f of x would goes to a value, let's say L, or in this case, f of a. So that is the actual value of the function at the point a. So if the limiting value is equal to the actual value of the function at that point, we say that the function is continuous. Now, if we consider this case, point or removable discontinuity, so if we are approaching 4 from the left-hand side like this, so this function approaches 4. From the right-hand side, it also approaches 4. So we can say that limit exists. So limit x goes to 4 of f of x, this is equal to 4. But the limiting value, but the actual value here, let's say f of 4 is not defined. Okay. Or it could be defined like this, like here, 6. So then also the limiting value, in both cases, if it is not defined or it is defined but some other value, so in both cases, the limiting value is not equal to the actual value. So we say that it is point or removable discontinuity. Okay. So this is the first type of discontinuity. So removable means that you can remove this discontinuity if you redefine the function at 0.4, f of 4 is equal to 4. If you redefine like this, then the function becomes continuous. Okay, next we have jump discontinuity. So it's number 2, jump discontinuity. So let me show you by graph. Let's say we have a function like this. Then we have like here something like this. So normally we can just an intuitive definition of discontinuity is when you are drawing this function. So if you need to pick up your pencil from one point to another, then we can say that the function is discontinued. But looking at the limits, we classify the function to be a point discontinuity, jump discontinuity, or asymptotic discontinuity. Now, drawing this function, if you're drawing like this, you come at that point, but then you need to have a jump here and start drawing again. So this is called jump discontinuity. Okay, what does this mean? This means that from the graph, we can see that limit x goes to, let's say this point is a, x goes to a f of x is not equal to, if it's from the negative side, is not equal to limit x goes to a positive of x. If we are approaching from the positive side, the function approaches this value. And if we are approaching from the negative side, the function approaches this value. So that's why it is called jump discontinuity. When the limiting values are not equal, we say that this type of discontinuity is called jump discontinuity. And then number third, we have asymptotic discontinuity. Discontinuity. So there is an asymptote like this. Let's say here, this, and we have a function this and like this. So by drawing this function, I need to pick up my pencil as well. So this is also a discontinuity. Well, we can see that from here, as we trace the function from the left-hand side, let's say this is the x equal to a point. This is the vertical asymptote. So limit x goes to a from positive side or from negative side. From negative side, you can see that as you're approaching this point a from the negative side, the function approaches negative infinity. But we don't write negative infinity. We say that the function is unbounded. X. This is unbounded. Also, from limit x goes to positive a of f of x, it goes to positive infinity here. You're tracing the function from the right hand side. So it's also unbounded. So if that is the case, that the limiting value from right hand side and left hand side are both unbounded, then we say that this type of discontinuity is called asymptotic discontinuity.